Hello, hello. It's not TDD, it's TBD, as in to be determined. So the thing was a little over a week ago. Nadia contacted me that one speaker canceled. I was like, "Can you do it?" I was like, "Yeah, I guess. We'll see." Um, Most of the talks that you saw today had a lot of content. Some, like Elena, were so filled with content I could barely follow. It was really good. So now I give you my talk, which has absolutely no content. So this will be easy to follow. And yeah, so the title stayed that because I'm really lazy. And I couldn't come up with any title. And yeah, again, no title, no content. But I came here yesterday to check if my Mac works on this displays, and sort of worked, like you saw before. And saw this particular configuration of this room. So I want to do this. I want to do a Mexican wave, and we'll start here, if the mic still works. And we're going to go across the room there and then back. OK? And don't be Trump. Like, not in this particular case, but like in general, don't be like Trump. OK, so again, let's go. Starting here. Oh. And back, and back, and back, and back. Yay! OK. So, this is you. That's you. And after my talk, there's party. So, sorry. So the faster I go, the faster you get to the beer. So this is probably But if you wanna interrupt me, feel free to ask questions. I do actually have some content, not much, but I do have some. And yeah, feel free to ask. Don't wait till the end. I'm the last, so they probably won't wait. Everyone will just go for a beer. So who am I? For those of you who don't know, obviously I'm a developer. I'm also the organizer of Ruby Slovenia, which is where I come from. I have stickers, so if you want the stickers, come at me later. I'm also a runner, at least I want to be. I'm a coffee connoisseur, which means, oh no, I'm an event photographer and coffee connoisseur. Yeah, so everything. Which basically means this is what my Instagram looks like, just coffee. And I'm special. So the content that I would like to talk about today are flame graphs. So who here knows what are flame graphs? That's very disappointing. And flame graphs are the only occasion where it's allowed to use this transition in Keynote. The only occasion, like never use this ever. But in this case you can. So basically what are them is basically it shows you where software is consuming, how software is consuming CPU. So you can, as the name suggests, find the hotspots and optimize there. So Brandon Gregg is the guy who came up with them. And he works at Netflix, and they had a problem because it was slow, one part of the code, and the only thing he had was dtrace. And this is what dtrace gives you. This is just 10% of the code he had to optimize, and it's, I mean, you don't know where the problems are, but this is how dtrace looks. And he said, okay, this is unreadable. What can I do? And he played around a bit with visualizations and stuff, and he came up with this. I mean, this was before, this is after. I mean, come on. This is just insane. It's insane. So basically, what are flame graphs? Every box represents a function, a merge stack frame. I will explain later. The y-axis, so the vertical one, shows the stack depth. So what are all the functions that were called before, or how did the function get called in the end? And yeah, everything beneath is ancestry. And the x-axis is, unlike most other visualizations you do, show you what happened in the app by time. In flame graphs, it's merged and sorted by alphabet. The reason it happens is, I don't know if you know how CPU works, but they are really, really fast, and it would be impossible to read anything if there were just lines. So you basically group similar stuff together, and then you can read it and you see where the problems are. And the box width shows the total time that thing was on CPU. Let's go one by one. So a function. Every box is a function. So let's say A is a function, but also are all the others. So every rectangle represents a function. Stack depth. So this means we go in the other direction. This function called this function, B called C, C called D, and so on. You can see what was on the CPU by the top. Basically, what's on top is what's directly on CPU. So now this was running, that was running for that amount of time. This was running for that amount of time, and everything is relative. So these are not absolute times. The width is always 100% of the time you were profiling. And yeah, ancestry. So F was called by E, E was called by C, C was called by B, B was called by A. And like I said, it's sorted by alphabet. So for example, here you can see B and G, then you can see C and H, and here D and E. And yeah, like I said, the width shows the total time on the CPU. So this was for A, for example, and for every other as well. So let's do something different. Which function is on the processor the most? F, right, F. Why? Because the top edge shows us what's on CPU directly. A, like some of you answered, is the ancestry. So let's say this is our main app. This is rails.app, whatever. And it just goes up. Next question. Why was F on the CPU? Yeah, right, it was called by E, which was called by C, which was called by B, which was called by A. Come on, follow, I'm explaining this. No one is working with me. So how does B compare to G? They were both called by A. What else can you see if you just look at? Yeah, it takes about 10 times. So looks like B is running about 10 times as much as G, which means, I don't know, let's say that G was an active support or whatever. Yeah, you could probably optimize it, but it's probably irrelevant because your problems probably lay in B or C. Like here is where the slow parts are. So they tell you where not to optimize flame graphs. Like they tell you not to go where it's not wide enough to make sense. Why rerunning F is sort of why we already answered. So yeah, A chose B, which chose C, chose C. Okay. So yeah, this is how they look for real. Like I said, it's ordered by alphabet. This is some MySQL stuff from the blog post that I'm basing this on, and it shows the stack depth. So you see the bottom line was on the CPU the whole time, and it called something that called something else, and you can see they start getting narrower and going to this tree sort of structure. So how you can use this in Ruby, or probably you can use it in any language, but how you can use it in Ruby, the gem called Flame Graph by Sam Saffron. And basically, it uses StackProf underneath, which uses RB profile frames, which is a C API added in, I think, 2.1 or 2.0. I'm not exactly sure. But the point of this API is that it's really low level. It performs no allocation, adds minimal CPU overhead, which means you could technically run this in production environment. I, for example, had a problem. I'm sure most of you are familiar. I'm from TopTal. We have an amazing blog at toptal.com/blog. And one of the things we do on the blog is, before it's published, the editors take a look at it, that it has a right amount of links, that it has the right amount of external links, keywords, stuff like that. And in order to look at the, I'm only focusing on this part of the crowd. In order to see where are the bottlenecks, or which keywords are missing, or what links are missing. You have to analyze the blog post. Now, the problem is there are some blog posts which are very technical and go really in depth, meaning they are almost, I would say, something that you could publish in a paper. There's a lot of code there. There's a lot of examples. There's a lot of Markdown. And yeah, we use Markdown. So basically, this is the flame graph that was generated. And the thing is, so we are grading the post, and we are checking for keyword count, for links count, for external links count, whatever. And for one particular blog post, it was, as you see, taking over a second, or about a second, which means in 30 seconds, we only were able to do it like 33 times, which is really, really slow when you have to edit the post and save it and wait for 1 second. It's stupid. So yeah, I ran flame graph on this because it's sort of extracted or like really modular inside our app. I was able to do it completely in isolation, and that provided me with this quite simple flame graph, meaning there is no Rails code, almost no Rails code under it, no rec stuff, no requests, nothing like that. But immediately you can see the colors are similar, and you can see the shape. Like this green stuff, like it's repeated 10 times or even more probably, and it looks similar. So maybe we're doing the same thing. And so what you can do, hopefully internet works. Sorry. Here we go. Someday now. Okay. So yeah, this is what. What's with the Wi-Fi? Come on. Don't use Tinder. Let me do this. Anyway, so if it eventually refreshes, it will show. Oh well, I can do it without this. So yeah, what you see if you, oh wait, no, I can open offline files. It's on Dropbox. Just a sec. Yeah, I loaded it, but I have it offline now, which is even better. So yeah, finally, okay. So we have these shapes which look very similar. So one thing you can do, you can hover over it. And I don't know if anyone beyond the second row sees this, but on the bottom, it shows you where the location of this function is that you are hovering on. And I saw here that all these, oh, by the way, colors. Yeah, I almost forgot. So colors represent the source of the function, which usually is gem or your application. And in this example, like cram down is this green-yellow, and I saw that this is all cram down. So, okay, apparently we're parsing the same thing 10 times. And yeah, obviously I found that this is what's going on. So I cached it, and I got it down to 8 per second, or like 7.5 performance improvement. And then I looked a bit more into what's going on, and I got it down to 9.4, or almost 10x improvement. And I mean, this is huge. We got it down from 1 second for the worst performing blog to around 100 milliseconds. And just from seeing the shape. And I could probably now see that like there is no point into optimizing in the right part. The cram down stuff is slow in this particular case. But I could take some other blogs, some other posts which are different, and see where the bottlenecks in my code are. But immediately from this tree, the first one, I saw that the problem is in somewhere. Why are we calling this 10 times? It looks exactly the same. And yeah, it did. We added some memoization, and we got there. So now we have to write this down. I'll wait. No, I'll post this soon. And yeah, these are really good. The first is actually a blog post by Greg, who explains how he got the idea, how he did it, and the whole first case on how he optimized that for Netflix. The second is Flame Graph Gem, which I was just talking about. But there are these two, Rec Mini Profiler and Ruby Profiler, which are two gems that you can potentially use in production and add really little overhead, and you can just see the flame graph in production for most of your websites. And the main thing I have from this is that I see where not to optimize. So there's no point in getting into active support or whatever, memoization, whatever, and optimize there, because I see that only takes like a tenth of a, or probably even less of what I'm doing. This is where the meat of the method was. Right? There was no point into going, and this spikes on the end. The problem was here. So yeah, flame graphs show you where to focus, and they help you find places where to optimize. And they also show you where what called something, which is also, sometimes you're debugging and you don't know which method calls this, or why am I getting this weird result, where is this getting lost, who is monkey patching my method, and which usually happens. And flame graphs is one of those things that like show you the whole stack depth, and you can just go one by one and you can see where it comes from. And what's even more, if I go back to here, okay, yeah, so like I said, when you hover, it shows you where it came from, but if you click on it, it actually shows you the whole stack trace. And you can go down and you can see that it was from my development, Flame RB, where I called it, and it was line 22 generate, and then it's collected in Stack Profiler, and up and up and up we go to the services graders, keyword grader, and I see how I got there. It's really good to see the whole stack trace. Yeah, so use them, they're cool. Again, this was all the content I had, so hopefully you got something useful out of it. I have stickers. These are Ruby Slovenia stickers. I can explain what they mean to you, because it's boring. I don't want to bore you now. And thank you for your time. I know you all want to go for a beer, so ask me questions later, and now let's go party.
Okay, thank you, Miha.